So Nick, a follow for you, right? I mean, talked about the introductions to autonomy product development and where does performance evaluation fit in. What is a sign of a good, healthy data analysis performance evaluation pipeline? If you had to build, the world class, which I'm sure you already built that at Aurora, but if you had to kind of reinvent the wheel and sort of have it ideal, what are some of the components you consider as an anatomy of a good performance evaluation pipeline?
Yeah, for sure. I mean, admittedly, we're always working on it. Nobody's perfect, so it's definitely like an iterative process. I think is one of the key things. But I guess if I had to kind of break it down in a few layers, I think first and foremost is really about the data acquisition and signal capture. So we talked a lot about how you want a lot of data, right? But if you're going to get inundated or drowned out by that, then I think that's obviously a problem. So I think you need diverse inputs. So the majority of my team actually works on simulation test review, right, and defect burn down for the simulated environment. I think that's super important because it's impossible to drive every possible scenario that you may encounter within an operational domain. There's so many uncertainties and factors. So it's really important to have a robust and reliable simulation environment. My team personally doesn't work on hardware in the loop or hill type, but I think that's another important signal as we think about like the integration of our software and hardware. So that's another important part. And then real world data, certainly you can't beat it. I think for us, there's a couple of different types of real world data that's important to collect. So manual data collections where we can learn from our expert drivers, maybe what to do in different scenarios. And then that also is feeding into a lot of our labeling, perception labeling pipelines and whatnot. I guess moving on to the other two, processing the data, the differentiation and analysis. So, we really need to filter the signal. Because you can get inundated with the data, you really need to prioritize what you internally are going to define as high impact. Now, on the surface, that might immediately be safety critical or highest severity. But as you start to get closer and closer to launching a product, or once you have an actual product on the road, certainly you're going to hope, okay, we don't have safety critical issues anymore. And now you're starting to refine is like, what is a high impact from a product standpoint? What are our partners for Aurora? That might be, FedEx or Werner or Hirschbach, or maybe even Volvo. What are they going to care about as their product, as part of our partnership, is out there in the real world on the road? What are they going to care about, right? For their own brand, for their safety and their own product, right? So you need to prioritize high impact events, and I think that is important to make sure that your internal partners are all aligned on that. We talked a little bit about metrics and benchmarking. I think one key point I want to make here is that in my opinion, and this is a lesson that we've learned from Aurora, is that you really need to compare against expected performance. I think one issue that we ran into years ago is that we were evaluating on an absolute sense versus what our system was designed to do, or what the expected performance was. And so it's really important that you compare against what is expected. I can go into some detail there or share some examples later if you'd like. And then finally, actionable insights and feedback. We talked about the loop, and we're all going to just keep saying the loop because it's so important that it really is a flywheel and that we're constantly iterating. It's important to decide who's getting the data, how we prioritize that, and then how we integrate it into training data, software updates for future development.
Very well said. I think that's basically summing up your development life cycle, from end to end. And I think one equation sort of, that sits in my head all the time is essentially a dot product between your, frequency of exposure, severity of the event, relevance of that event to your product development. Because look, at the end of the day, we're always going to have these, 5%, 10% of the events which happen, extremely rarely. But when they happen, they're basically like finding like striking a gem in the mine, and then you sort of capitalize on that. Well said in terms of importance to your milestones and how does that actually feed into the end commercialization of the technology that we talk about. Melinda, your perspectives on this, maybe, if you can share an example where um, a good and bad both, right? Where we found a great example where, hey, if this was not for the pipeline or the performance evaluation sort of ecosystem we had built, we would have never been able to find. And something that we found, but was of a much lesser value and was more of a noise that led the team to go into a goose chase, and we ended up nowhere, but just sort of a dead end. We just elaborate on that.
Yeah, definitely. Yeah, and I think thinking about the examples that I've seen and how they kind of apply to what would a very healthy, or like what's the gold standard that we're striving to. Something that we're always trying to do at Motional, and certainly I think across the industry at all the organizations I've been at, certainly, is how do we push more and more testing further to the left? Meaning, how do we get more testing closer to the actual developmental changes? What tools can we have to kind of incrementally build the signal that we're getting? And really to do it cheaper and faster than what we've been able to do, right? We talked a little bit earlier about maybe the easiest or the best, the simplest way to get feedback is on-road driving, right? That's kind of straightforward, and even that comes with all of its own challenges, but of course that's the most expensive, the most labor intensive, and the most risk when you're thinking about testing. Of course, you want to eliminate as much risk as possible by doing testing earlier in simulation, like Nick pointed out. With hill testing, we can really do a lot before any code actually makes it onto the vehicle, and we should, and we kind of have an obligation to do that and continue to improve those systems. And I think that to your original question, Sahil, of examples of where we've seen it, I think those are some of the proudest moments, is when we've actually been able to catch potentially problematic issues earlier in the test pipeline. We didn't need it to go onto a vehicle. We're able to catch it in simulation, in hill testing, even close course testing, right? Things that you're able to see earlier in the testing pipeline, I think, are some of the most impactful. And as you can, every time you catch one, you might do a post-mortem and figure out, how could we have caught this even earlier, right? What steps could we fit into our, every time a developer pushes a piece of code to the cloud, can we run, CI tests? Can we catch something really, earlier, so that we don't even have to get to the point where it got to?
Makes sense. I mean, at the end of the day, we also, to your like moving to the left, right? The goal that we all have is to minimize any surprises, right? Things that we don't expect, right? I mean, if we have deficiencies in the system, we have failures that we're aware of, and finding that ahead of your driverless deployment, I mean, that's fairly good. I mean, that's essentially you're validating the hypothesis that the things that you knew ahead of time, you're kind of seeing it from the real-time data. In fact, I remember quite a few situations where you and I worked on. We had things that we found in the field, and we were like, hey, what can we do to move this up left in the chain? And we found gaps and holes in the processes and in the tooling and in the teams that we have. Then we later on fix them, and then over a period of time, that 50%, 60% becomes a long tail of 90%, and then you have few specific types of cases that you got to solve in the last 5-10%. Which, by the way, becomes a like, I don't want to underappreciate that last 10%, because that becomes the difference between launch, go, and no go, because ultimately you need to be extremely confident on where you are in your whole system when you do launch, like your team is going to prepare for in the coming months.